Alright, so in this video we're going to go over geometric series. Now, we're going to go over the finite geometric series in this video and an infinite geometric series in another video. So what is a geometric series? Well, it's a sum of terms from a geometric sequence. Kind of like an arithmetic series and sequence, same principle behind geometric series and sequences, except the main difference where you multiply and divide instead of add and subtract. So infinite means you're using a set number of terms. Right? So n is going to equal an actual number. So let's look at an example. We have 1/2 plus 1/4 plus 1/8 plus 1/16 plus all the way up. We're going to have 10 terms. All right, this is your formula. Your sum equals your first term times 1 minus r to the n. R is your ratio, n is your number of terms, divided by 1 minus r. At first glance, it looks like this is going to give you 1, but remember, the ratio up top is raised to your number of terms, that n is an exponent. All right, so let's look at a problem and put this to work. Actually, we're going to do this problem, but we're going to do it here so I have more room. So we have 1/2 plus 1/4 plus 1/8 plus 1/16 and so forth, and we're going to do 10 terms. So the first thing we need to do is we need to fill out, we need A1, we need R, we need N. Well, N, we know there's 10 terms, all right? A1 is 1/2. And remember, to get your ratio, you take one number, divide it by the number before it. So that's going to be, flip out to be times 4 over 1, 2, 1, 1/2. So our ratio is 1/2. So now we just plug into our formula. Our sum equals 1/2 times 1 minus r, which is 1/2, raised to our number of terms, which is 10, over 1 minus 1/2. That is going to be our sum. So you put this in your calculator, and your sum equals 0.999. Now, our sum is 0.999. You might be tempted to round this to 1 because it is so close to 1. But don't round your answer. All right? Do not round it. Leave it as 0.999. Do not round it. Okay? So this is how you find the sum of a finite geometric series. Now, there's also a sigma notation with the geometric series. All right? So the sum from 1 to 8 of 2 times 1/3 raised to j. Since j is an exponent, that's your key that this is a geometric sequence. All right, since j is an exponent, that is your key that this is a geometric sequence. So we need A1. All right, and then so the sum equals A1, 1 minus r to the n over 1 minus r. So we need our first term, we need r, we need n. All right, now when you have this, whatever is in the parentheses raised to the exponent, that's your r. That is your ratio. Our ratio for this problem is 1/3. Our number of terms. You find your number of terms the same way you did for an arithmetic series. Top term minus the bottom term, add 1. Or if this starts with 1, you take the top number. Number of terms is 8. Now, we have to find A1, so put 1 in for j. So it's going to be 2 times 1/3. Raised to the first, well, that's just 2 times 1/3, which is 2/3. So our first term is 2/3. So our sum equals 2/3 times 1 minus 1/3 raised to 8 over 1 minus r. Plug this into your calculator, and remember, do not round, and your answer should come out to 0.9998. All right, do not round this to 1. Leave it alone. So, The main difference between the sigma notation is if your variable is your exponent, it's geometric, and whatever is in the parentheses raised to that exponent, that is your ratio. Then you just find your first term by plugging in your bottom number, and then the rest of it you just finish the formula. Alright? So this was kind of a short video. This has been your finite geometric series video. Feel free to watch it as many times as you need to. Make sure when you come to class tomorrow you're ready to work some problems. See you tomorrow.